Copper is dead, the new wiring will shock you. The wire snapped without a sound. Lights dimmed across 3 neighborhoods, servers coughed, and a hospital alarm blinked red. An engineer stared at a heat-scorched coupler and whispered, "We spexed copper, this isn't copper." 3 hours earlier, procurement chose a cheaper alternative to beat a deadline. It worked until the surge. That small switch rippled across a grid already stretched thin by data centers, EV chargers, and heat. The quiet pivot away from copper has begun, not out of preference but pressure. Today, we're rewinding to see how copper took the throne and why the crown is suddenly slipping. How copper took the throne. Copper didn't win by luck. It won because electricity needed a metal that could move current with minimal loss, bend without breaking, and survive decades in walls, motors, and substations. When Edison and Westinghouse were wiring cities, copper's combination, high conductivity, ductility, resistance to corrosion, made it the obvious choice. Aluminum was lighter and cheaper, but it ran hotter at the same load and demanded thicker gauges. Steel was strong but hopelessly resistive. Silver was better but ruinously expensive. Copper settled into the sweet spot, performance at a price industry could swallow. Then came scale. Railroads, telegraph networks, urban lighting, each wave embedded more copper. By the time post-war suburbs unspooled across continents, copper wire was as invisible and essential as plumbing. Utilities standardized around its properties, codebooks ossified to its limits. You didn't design wire, you designed copper. Meanwhile, the mining machine learned to feed that habit. Chile's porphyries rose to dominance, Peru and the US followed, Africa's copperbelt in the DRC and Zambia filled the gap. Smelters multiplied where power was cheap, refineries clustered where demand stayed steady. The system ran on 2 rails, primary metal from mines and secondary metal from scrap, both refining into cathodes at 99.99% purity, both indistinguishable to a motor or busbar. Industry gave it a nickname, Dr. Copper, because its price tracked the patient, the global economy. When factories hummed, copper climbed. When recessions hit, it sagged. The story felt stable, demand rose roughly with GDP, mines expanded in step, recycling topped off the tank. It wasn't perfect, but it worked. Then the curve bent. Electrification turned copper from a cyclical barometer into a structural bottleneck. Each EV packed 2 to 4 times the copper of a combustion car. Wind turbines needed miles of cabling and heavy-gauge coils. Solar farms tied inverters to substations with thick veins. And data centers, those quiet cities of heat and hum, asked grids to move colossal loads with pinpoint stability. Supply didn't bend with it, ore grades drifted down. Pits deepened. Environmental scrutiny tightened. A modern copper mine often takes a decade or more to permit and build if it clears the social and ecological bar at all. Smelting concentrated in a handful of countries, refining concentrated even more. Recycling helped, but scrap flows lag reality. The copper you install today won't come back for 20 to 40 years. Above-ground stocks are rising, but not fast enough to catch the new floor of demand. That's how copper took the throne, by being good enough everywhere for a very long time, and how the throne now feels wobbly. Not because copper failed, but because expectations changed faster than geology, permitting, and infrastructure. Here's the twist. When systems strain, engineers start swapping. In transmission, aluminum is already standard in overhead lines, lighter, cheaper, acceptable with larger cross-sections. In some low-voltage profiles, copper-clad aluminum shows up, sometimes responsibly, sometimes not. In telecom, fiberglassed copper on speed and signal integrity. Now every cloud region pulls miles of it. In motors, manufacturers experiment with designs that reduce copper mass per kilowatt. Even PCBs trim copper thickness where heat budgets allow. Those choices are rational in isolation. The danger is accumulation. You can build a substation with aluminum busbars, but you'll manage higher thermal expansion and different jointing. You can run feeder circuits with copper-clad aluminum, but every termination becomes a risk if a torque spec is missed. You can fill campuses with fiber, but backbone power still rides metal. Substitutions solve local problems and push complexity into the joints, connectors, and maintenance windows, exactly where systems fail in heat waves and surges. And the geopolitics got louder. Where you mine copper, where you smelt it, where you refine it, these are different maps. Chile dominates ore, China dominates refining. The DRC grows fast in mined output but refines little at home. That separation worked when trade was smooth. It's less comfortable when tariffs fly, contracts get renegotiated, or local communities demand more value kept on shore. Meanwhile, price volatility loops back into design. When copper spikes, cathode tightness travels quickly into motor costs and wiring bids. Automakers trim copper weight, builders hunt alternates, utilities delay upgrades. Those deferrals stack into fragility, stressed lines, undersized conductors, warmer switchgear. So yes, copper took the throne because it balanced physics and economics for a century. But thrones aren't guarantees. They're bargains renewed every day by miners, smelters, code writers, engineers, and the people who live near pits and substations. Right now, that bargain is being renegotiated in boardrooms, ministries, and factory floors, often quietly, often under deadline pressure. Get this, the system will keep working until it doesn't. A single failed coupler in a hospital won't end the copper era, but it signals the new reality. Every substitution, every delay, every tariff nudges the grid off habits that made it stable. The question is whether copper matters. It's whether we can match what it did so well at the scale and speed the next decade demands. Aluminum on the wires, copper in the walls. To understand the quiet pivot, start at the poles. Overhead transmission went aluminum decades ago, not because engineers fell out of love with copper, but because gravity never does. Aluminum carries about 61% of copper's conductivity at roughly a third of the weight. Stretch that across 1,000 towers and the math wins. You make the conductor fat, aluminum strands wrapped around a steel core, and you buy less sag, less cost, and a line crew that doesn't curse every reel. Meanwhile, inside buildings, copper stayed, not out of nostalgia, but because buildings are a different world. Tight spaces, thermal cycling, mixed metals, torque specs that live or die at a contractor's wrist. Copper's higher conductivity lets you pull slimmer gauge wire through conduits without turning every bend into a heat source. Its creep is low, terminations stay tight. In a breaker panel, those boring traits keep lights on. Here's where it gets complicated. Aluminum is not one metal in practice, it's a family of alloys with temper histories. Join it wrong and you get galvanic corrosion. Torque it wrong and you get cold flow, microscopic slippage under pressure that loosens the connection. Those weaknesses are manageable if everyone obeys the book. Oxide-inhibiting paste, proper lugs rated AL-CU, retorque schedules. But the book fights real life, rush jobs, mixed boxes on a site, one missing label on a lug. A single oversight becomes a hotspot. A hotspot becomes a failure under summer load. There was a moment in the 1960s and 1970s when aluminum tried to move into the walls in a big way. It ended with fires and lawsuits and a long memory baked into code. That legacy still shapes decisions. When copper prices jump, proposals reappear. Copper-clad aluminum for branch circuits, aluminum bus and panels, hybrid solutions that blend costs. Some of those are solid when properly engineered. Some are shortcuts that rely on everything going right forever. The stakes aren't abstract. In data center alleys, utilities lay new feeders at a pace that felt unthinkable a decade ago. The spec might read aluminum bus in the yard, copper in the building, bimetallic transition pads at the wall. That transition is a fragile piece. 2 metals, 2 expansion rates, 2 ways to fail if a bolt stretches or a surface oxidizes. Engineers sign off because they must. There isn't infinite copper and budgets aren't bottomless. But every interface adds an if. Across oceans, substitution shows up differently. Telecom didn't wait. Fiber sprinted past copper on bandwidth and reach. That relieved one pressure, but it didn't free copper for everything else. The grid is still metal, motors are still wound. Even EV fast chargers, which live in a fibered world, feed on thick conductors and careful terminations. When automakers trim copper mass in motors, hairpin windings, tighter slot fills, they celebrate efficiency. They also tighten manufacturing tolerances and reduce repairability in the field. Meanwhile, procurement desks watch price spreads like weather. Treatment and refining charges fall, cathode tightens, cable quotes swell. A builder flips a spec, aluminum feeders instead of copper, same ampacity. On paper, it's clean upsized by code, approved lugs, correct compound. In practice, the installer's impact wrench becomes the hidden variable. On day 1, it holds. On day 700, under a heat dome, the joint breathes and a panel chirps. Now add geopolitics. Aluminum smelting follows cheap power, copper refining follows industrial clusters. Tariffs tweak those rivers. When one country raises the drawbridge, metal flows reroute overnight. A shipment meant for a Chinese rod mill is diverted to a US fabricator. A Latin American refinery slows on feedstock. A European plant idles on power costs. Designers downstream don't see the shipping manifest. They see a quote with a lead time and a price that forces a choice. Recycling could blunt the edge. Aluminum recycles with about 95% energy savings, copper with about 85%. But labor, quality control, and fragmented scrap streams play spoiler. High-grade copper scrap isn't always staying where it's generated. Some countries export the good stuff and import low-grade scrap back, with impurities that complicate refining. For aluminum, the alloy mix matters. The wrong scrap blend produces metal you can't confidently put in a connector rated for a hospital wing. There's a human layer people gloss over. Inspectors write up a panel and hand the contractor a punch list. The contractor knows the budget's gone and the client wants the ribbon cut Friday. The torque wrench comes out anyway, but a dozen other fires pull attention away. That's not negligence, that's reality meeting physics. Copper forgives more of those moments. Aluminum forgives fewer. So I keep saying aluminum on the wires, copper in the walls. Because that split captured a hard-won truce between cost, weight, and risk. It wasn't dogma, it was field wisdom. The quiet shift we're seeing doesn't rip that up, it frays it. A little more aluminum creeps inward, a little less copper shows up where it used to be assumed. The line between yard and wall blurs, one value-engineered change order at a time. None of this means aluminum is the villain. It means systems hate surprises. If we push substitution deeper, we have to upgrade everything around it: lugs, training, inspection intervals, even the torque tools in a journeyman's bag. Otherwise, the failure doesn't announce itself at the lab bench. It announces itself at 3 a.m. with a burnt smell and a blinking alarm. Photons replace copper's data rent. While that was happening in the substations, something else was happening in the ground. The world's largest consumers of electrons, cloud regions, quietly evicted copper from the long haul. Photons took the lease. Not because copper was bad at carrying bits, but because fiber made speed and distance almost free. To understand why, we need to go back to the last mile that wasn't last. In the 1990s, telecom wrung miracles out of twisted pair, DSL pushing megabits through copper that had been nailed to poles for voice. Every extra megabit cost sweat, better modulation, more repeaters, more heat. Then a single strand of glass started doing kilometers at gigabits with a light at each end and almost no loss. It wasn't a fair fight. Copper charged rent for distance. Photons didn't. Data centers made the pivot ruthlessly practical. Inside the halls, short copper links still make sense for certain racks, cheap, simple, low latency over a few meters. But step outside the building and everything that matters is latency, bandwidth, and electromagnetic immunity. Fiber wins all three. Lightning can dance on a fence line and your signal doesn't care. You can run parallel strands the width of a hair and multiply capacity by lighting different colors through the same glass. DWDM turned a single route into a multi-track highway. What nobody knew at the time was how fast the appetite would grow. AI training clusters aren't just racks, they're neighborhoods of heat and hum, each node screaming for backhaul. Cloud regions stitch themselves together across states because no one campus can hold the load or the risk. Those stitches are glass. Lateral lines to peering points, glass. Long hauls across deserts, glass. Subsea cables stitched between continents, miles and miles of armored glass humming in darkness. There's a human story tucked in here. A field tech in Nevada told me their crew used to carry copper reels and splice kits. Now the truck has fusion splicers, OTDRs, and cases of clean wipes. The failures changed character. Instead of chasing water intrusion in a copper binder, they chase microbends, a crushed conduit, a dirty ferrule. It's still the same job, keep the bits moving, but the physics moved under their boots. This is where it gets counterintuitive. Fiber reduced copper's data rent, but it didn't relieve copper's power burden. Every glass path needs lasers, repeaters, transceivers, gear that drinks electrons. Every switch that pushes terabits throws off heat. So while photons carry the bits, copper still carries the amps. That means the more fiber we lay, the more copper we need in feeders and panels to feed the optics that made fiber essential. The pressure didn't vanish, it shifted lanes. And the geopolitics crept in again. You can draw the map of power in the data age by tracing fiber landings. Countries fight to host them, regulate who touches them, and mandate redundancy. When a subsea route snaps, markets feel it. When tariffs throttle the flow of optical transceivers, build-outs stall. Suppliers diversify sources of glass, performs, and lasers like miners diversify ore. It's the same game: concentration, choke points, alternatives, played with photons instead of cathodes. Meanwhile, builders learned a hard lesson. Fiber is cheap until the trench isn't. Permitting delays, right-of-way fights, rock you didn't expect. Suddenly your perfect least-cost route turns into detours and blown timelines. That's when good enough shows up in proposals. Reuse an old conduit that wasn't designed for bend radius. Pull too many strands through a crowded vault. Accept a connector that should have been cleaned twice. The problems don't announce themselves day one. They appear 6 months into peak load, when a link flaps and a failover that never got rehearsed takes a hair too long. Then there's the substitution feedback loop. As fiber pushes deeper, copper manufacturers pivot toward power products, busways, switchgear, EV feeder cables. In a tight cathode market, capacity follows higher margin orders. That's rational. It also means the next time a hospital asks for high-spec copper data cabling, yes, some still do for specialized EMI environments, the lead time stretches. A metal that lost one domain gets more precious in the one it kept. The irony: fiber's dominance creates new reasons to be picky about the copper you keep. Clean grounds matter more when you're feeding sensitive optics. Transient suppression matters more when your entire operation depends on a glass thread that hates rough handling. The spec sheets for lowly power rooms start to look like lab notes. A missed bonding jumper can ring as loudly as a cut fiber. So did photons replace copper? For data rent, yes, brutally, decisively. For power, no, and the demand curve is still rising because every bright light on the end of a fiber needs electrons to glow. We traded one bottleneck for another and told ourselves it was progress. It is. It's also a reminder. When you solve the distance problem with glass, you make the amperage problem everyone's daily job. Motors and EVs, copper's last fortress. From their perspective, motors were supposed to be the safe zone. Engineers could shave copper from buildings and stretch aluminum on towers, but inside a traction motor there wasn't much to argue about. Copper wins torque density. It wins heat. It wins reliability when a vehicle spends a decade inhaling dust and rain and road salt. Now remember, the EV stack puts copper in three places that matter: the battery packs, bus bars, and interconnects, the inverters that chop DC into drivable AC, and the motor windings that turn electrons into motion. Each is a different negotiation with physics. In bus bars, you trade cross-section against temperature rise. In inverters, you fight switching losses and EMC. In windings, you chase slot fill, the percentage of a stator slot stuffed with copper rather than air and insulation, because every extra millimeter becomes torque. Here's where it gets crazy. Automakers are doing two things at once: switching motor topologies and compressing manufacturing tolerances. Hairpin windings, rectangular copper conductors bent into precise shapes, push slot fill past what round wire can achieve. That buys efficiency and shrinks copper mass per kilowatt, but it also makes the stator a precision object. A burr on a hairpin, a misaligned varnish cure, a tiny void near an end turn. Any of these become heat you can't afford when the highway is a 45-degree ribbon and the pack is at 20%. Permanent magnet synchronous motors change the game again. Magnets carry part of the field, so you can get the same power with less copper than an induction motor. Great in theory until Geopolitics walks in wearing a rare earth badge. If magnet prices jump or supply turns fragile, designs swing back toward copper-heavy induction topologies or hybrids that use fewer magnets. The fortress adapts, but the walls are still wrapped in copper. Meanwhile, a quiet copper diet is happening in the rest of the drivetrain. OEMs and Tier 1s trim mass and high-current cables with finer stranding and new insulation systems, push laminated busbars into tighter stacks, and polish every connector interface. That's rational. Copper is expensive and getting tighter. It also narrows margins for error. A connector that loved round wire might hate the stiffness of a hairpin busbar. A crimp spec that was fine at 400V might arc at 800V when a pin gets nicked. Field techs learn new failure signatures: a faint ozone smell after a fast charge, a flicker in the inverter that shows up only at one state of charge and one ambient temperature. And the chargers themselves. Fast DC stations are copper festivals. Massive feeders, fat DC cables, liquid-cooled leads to keep resistance manageable while you push 350 kW into a pack that's already warm. Designers are relentless about every milliohm. They also live with trade-offs that don't headline well. Make the cable thinner for customer ergonomics and you need more aggressive cooling. Use more aluminum in the upstream cabinet and your lugs and transitions become a maintenance schedule. The bill of materials isn't a list, it's a map of vulnerabilities. What nobody knew at the time was how fast demand would compound. Add up vehicle wiring harnesses, motors, inverters, onboard chargers, home chargers, and grid upgrades to feed neighborhoods with multiple EVs. Then add the buses and delivery fleets that never sleep. Each EV uses multiples of the copper in a combustion car. Multiply that by millions and copper stops being a component and becomes a gating factor. Price volatility doesn't just hit an OEM's quarterly. It shows up as design churn mid-program, as procurement pivots between grades and suppliers, as a software team rewriting charge curves to protect hardware that came in a hair different than the first prototypes. There's a worker at a Tier 1 plant in Ohio who still tells the story of a summer night when a small lot of hairpins arrived with a surface finish just out of spec. The varnish didn't wet perfectly. The motors passed end of line. The field return started 6 months later in Arizona. The fix was surgical new varnish chemistry, tighter supplier control, but the lesson stuck. When you squeeze copper mass, you squeeze the whole process. Every micrometer you remove comes back as discipline you have to add. Meanwhile, substitution nibbles at the edges. Aluminum in low-voltage harnesses in places that aren't mission-critical. Copper-clad aluminum in carefully controlled profiles. Even a few experimental rotor bars. Those aren't the heart of the fortress, they're the parapets. The keep is still copper windings, copper bars, copper buses, because when you ask for peak torque at a green light in August, the margins vanish. Upstream, the supply map tightens the screws. Mines take years, not quarters. Refining is concentrated. Scrap returns lag because the first big EV cohorts are still on the road. Recyclers prepare hairpin stators are disassembly puzzles, but the feedstock wave is years out. In the interim, OEMs hedge, lock multi-year cathode contracts, and quietly redesign for material efficiency that won't get a press release. So is copper's fortress unbreachable? For motors and EVs, it's the last place you'd bet against it. You can trade magnets for copper or copper for magnets, but you don't get away from metal that moves heat and current with minimal drama. The real risk isn't a single substitution. It's attrition, tighter tolerances, thinner cushions, more interfaces stacked across vehicles, chargers, and grids. The fortress stands. The moat is getting shallower. The coming supply gap. This is the moment everything changes. The demand curve stopped being a rumor and started showing up in orders. Grids are doubling backbones for AI load. EV factories plan millions of drivetrains. Utilities rush substation upgrades that used to sit on 5-year plans. On paper, copper supply is roughly 28 million tons a year. The near-term demand track plausibly heads north of 40 million within a decade. That isn't a price twitch, that's a structural gap. What nobody knew at the time was how hard it is to close that kind of distance. A mine is not a startup. From first drill to first ore can be 10, 15, even 20 years depending on permits, power, water, roads, and whether a community believes your promise will outlast your press release. Some projects in North America have taken decades. Meanwhile, ore grades are sliding, less copper per ton of rock, which means more energy and water per pound and more tailings to manage. The calendar is the enemy, so is geology. Refining even tighter. Mining is concentrated, refining is concentrated more. Chile dominates ore, China dominates the midstream. Smelters and refineries do not pop up in a quarter. They follow cheap, reliable power, stable policy, and environmental tolerance that's getting stricter everywhere. Treatment and refining charges that once fattened margins have thinned, at times even turning briefly negative, squeezing processors just when everyone wants more cathode. Add tariffs or export rules, and entire flows can reroute over a weekend. Recycling should be the pressure valve. Copper recycles well, secondary metal performs like primary with far less energy, around 85% energy savings versus primary. But collection and purity are bottlenecks. The copper you need is tied up in buildings, motors, and grids that live for decades. Above-ground stocks exist, but the urban mine doesn't empty on demand. Some countries export high-grade scrap and import lower-grade back, chasing short-term arbitrage while polluting the long-term feedstock. You can't run an EV program on wishful shredding schedules. Analysts began putting numbers to the feeling. Banks modeled deficits that don't close until the 2030s without unprecedented mine additions. Forecasts talk about millions of tons of extra demand, 7 to 9 million, arriving faster than credible supply. Traders see it in spreads between exchanges that whip unpredictably when policy moves yank cargoes from one route to another. OEMs feel it in lead times and in quiet supplier notes asking for flexibility on spec, because the last cathode shipment didn't match the first. Meanwhile, Africa's copper belt is waking up hungry. The DRC is now a top-tier producer. Zambia is pushing a revival with big capital and friendlier codes. New expansions at Kamoa-Kakula and fresh cash into old names like Mopani and Konkola. There's motion, and a lot of it from Chinese and Gulf capital. That helps, but it doesn't erase refining concentration or infrastructure limits. Rail, power, acids, ports, every constraint turns into a queue. And a new political mood runs through producer capitals. Keep more value at home. Exporting concentrates out and importing cathodes back looks less attractive to any finance minister with a deficit and a youth bulge. If you want the human version of supply gap, listen to procurement managers in OEMs and utilities. They used to treat copper like oxygen, always there, priced by weather. Now they sign multi-year offtakes, hedge volumes like airlines hedge fuel, and task engineers to cut kilograms without cutting performance. A car platform drops 10% copper mass in its motor windings. The inverter team pays the heat bill. A utility upsizes aluminum on a feeder. Operations inherits a new maintenance schedule for mixed metal joints. The savings are real. The complexity is realer. Price is the megaphone. When copper runs, EV wiring looms get redesigned mid-program, charge curves get rewritten to protect hotter connectors, and fast charger rollouts slip a quarter because the cabinet vendor couldn't get the bus bars they promised. Data centers postpone one campus and overbuild another where switchgear showed up. A hospital pushes a wing opening because the last test threw a thermal alarm on an AL-CU transition no one loved. Each delay looks small. Together, they're the shape of a constraint. There's a geopolitical layer nobody can ignore. Tariffs in one capital lead to stockpiles in another. Strategic reserves aren't just for oil anymore. Copper inventories become policy tools and panic buttons. Export restrictions on scrap in one block tighten refined markets in another. Sanctions shift trade to quieter ports. Smelters build friend-shored blends of concentrate to keep their ESG scores intact. The map is a living thing. So what fills the gap? All of it, and not fast. New African tonnage, Latin American brownfields, a few long-gestating projects finally crossing the line. Refining capacity where power is cheap and rules are clear. Recycling that moves from informal to industrial with traceability that banks accept. Design efficiency that trims copper per kilowatt without eroding reliability. And substitutions where they make sense, paired with the training and hardware that keep joints honest. Here's the part that matters for everyone not trading commodities. The gap won't look like empty shelves. It will look like schedules that keep slipping, quotes that require approvals 2 levels higher, specs that quietly change, and failures that cluster during heat waves and storms. It will look like 1,000 rational decisions made under pressure, adding up to a system with less slack than it used to have. Dr. Copper used to diagnose the economy. Now it's diagnosing the transition. The patient's heart is strong, the arteries are narrow. Where the ore lives and the choke points. To understand the strain, trace the map. Copper lives in a few big belts and almost everything else pivots around them. In the Andes, Chile's porphyries still anchor the market, massive low-grade systems that look endless until grades slip by another 0.1%, and every ton of rock gets heavier. Peru runs just behind, with world-class deposits locked to high plateaus and politics that swing between welcoming and wary. Across the Atlantic, the African copperbelt is coming fast, southern DRC and northern Zambia, where new money meets old geology and the logistics are as critical as the ore. Meanwhile, China isn't the biggest miner, but it is the midstream. Refineries that can turn concentrate into 99.99% cathode at industrial scale, and the cluster matters: sulfuric acid supply, power, ports, and a workforce that's done it at volume for 2 decades. That concentration was convenient when the world agreed on rules. It stings when tariffs, sanctions, or power rationing force detours. Mining and refining are different maps. The distance between them is where risk hides. Look closer and you see the choke points. In Chile, water and power aren't footnotes, they're gates. Desal plants push brine uphill to keep mills turning. A drought can shave output. In Peru, social license isn't a PR phrase, it's a calendar. A road blockade can sideline a quarter of national exports in a week. In the DRC, the ore is exceptional, but roads, rail, and ports decide throughput, and cross-border queues into Zambia or down to South Africa can erase a margin. Add resource nationalism. Higher taxes, contract reviews, beneficiation mandates, and timelines stretch. Then there's grade. The Andean giants are deeper and leaner than a generation ago. Every 0.1% drop in head grade is more energy, more water, more tailings per pound. Projects that penciled at one grade need new math at another. The best new tonnage is often in places that want more than royalty checks. In Africa, governments are right to push for value at home: smelters, sulfuric acid plants, jobs, but the build-out is slow. A smelter needs steady power and clean air permits. A community needs trust that outlasts one cabinet. Treatment and refining charges. The fees smelters charge miners used to be a buffer. Lately, they've compressed, even flipped negative at moments when concentrate outpaced processing. When TCRCs are thin, smelters slash maintenance or delay expansions that everyone needs. It's a feedback loop. Miners push to ship more, processors struggle to add capacity when margins vanish, and refiners downstream ration cathode to those who planned years ahead. Now follow one shipment. A bulk carrier leaves Antofagasta loaded with concentrate headed for a Chinese smelter. A tariff announcement hits, the cargo is resold en route, the ship changes destination. The smelter that expected that feed scrambles for alternate supply blends a different concentrate slate to keep impurities within spec and nudges output. A European fabricator that counted on those cathodes now faces a lead time slip. Their rod mill runs half a shift short. Downstream, a cable plant stretches inventory by thinning safety stock. None of those decisions make headlines. Together, they draw the outline of fragility. Strategic stockpiles add another layer. Copper isn't oil, but reserves are creeping into policy playbooks. When an economy faces a power build-out or an EV ramp, holding metal smooths shocks. When a country signals it might restrict scrap exports to keep material onshore, secondary flows tighten elsewhere. Europe's talk of limiting recyclable metal exports to feed its own circular economy sounds green and domestic. Downstream, it's one less pressure valve for smelters that rely on clean scrap to balance their inputs. Then there's the bottleneck nobody priced until recently: sulfuric acid logistics in the copperbelt. Oxide ores need acid for leaching. A smelter shut down miles away can starve a heap leach, and hauling acid over bad roads is a risk no one loves. In Zambia and the DRC, expansions at Kamoa-Kakula and Mopani come with parallel investments in acid plants and power lines. Growth is real, so are the constraints. Look north again. The US and Canada have ore, but permitting is a timeline by itself. A deposit in Arizona can spend a decade in studies and courts before a shovel hits dirt. When policy winds shift, projects roar back, then elections shift them again. Meanwhile, investors chase friendshored tons in Chile, Peru, and Africa, hedging political risk with offtakes and equity stakes. Gulf and Chinese capital are deep in the copperbelt. Western miners are pushing to diversify away from single-country dependence. Everyone's right, nobody's fast. Recycling should relieve the map. But secondary copper's geography is also concentrated, where manufacturing lives scrap lives. If high-grade scrap leaves on a ship and low-grade returns, refineries see impurities and cost. Traceability mandates grow, buyers demand ESG data with metal, and informal recycling in one country can block entry in another. The urban mine is real. Its customs paperwork is too. So when you hear where the ore lives, hear the rest. Where water runs, where roads hold, where permits stick, where communities say yes, where smelters breathe, where tariffs don't turn ships. Copper isn't scarce in crustal terms. It's scarce in the paths we've built to move it from rock to busbar without breaking trust laws or margins. That's the map the next decade must redraw while the load keeps rising. China's parallel bet: aluminum, refining, and control. While the Andes and the Copperbelt define the rock, China defined the midstream. 2 decades ago, Beijing looked at its growth curve and made a blunt choice. If you can't mine enough, own the bottlenecks. Smelters, refineries, rod mills, stack them where power is cheap and logistics are close to factories. Then stitch the upstream with offtakes, equity stakes, and quiet diplomacy. It wasn't theory. It was industrial policy with a stopwatch. Here's where it gets precise. China didn't just add copper refining, it built a gravity well. Today, a massive share of the world's concentrate lands on Chinese docks and leaves as 99.99% cathode, wire rod, and semi-finished products, that clustering compounds. Sulfuric acid from smelting feeds chemicals next door. Anode slimes yield precious metals one building over. Ports load containers of cable and motors headed to the same countries that sent concentrates in. The margin lives in the loop. Meanwhile, aluminum became the other lever. Overhead lines were already aluminum's home turf, but China pushed the alloy deeper, not to replace copper everywhere, but to reduce the places copper was non-negotiable. In conductors, advanced ACSR and ACCC profiles, better heat-resistant alloys, tighter quality control. In motors and appliances, selective aluminum windings in cost-sensitive segments, backed by design tweaks and coatings that made the trade-off livable. Each success freed copper for where it mattered more, or for export orders that bought time and influence. What nobody knew at the time was how far the command over refining would reach. When treatment and refining charges collapsed, at points even turning negative, most smelters would have tapped the brakes. Chinese plants, cushioned by scale, integration, and policy support, kept running. It pinched margins, yes, but it also defended market share and kept downstream factories fed. A processor in Europe or Japan couldn't eat those losses forever. Capacity drifted toward the cluster that could. There's a micro story that explains the macro. A mid-size cable maker in Southeast Asia used to split cathode purchases between 3 refineries in different countries. Lead times were predictable. Then a tariff volley hit, premiums swung, and one supplier missed a shipment. A Chinese trader stepped in with cathode from a different Chinese refinery, bundled with a rod supply contract and a financing line. The buyer didn't just switch suppliers, they joined a system. Next year, their anode scrap had a home. The year after, their equipment upgrade came from a Chinese OEM with service techs on call. That's stickiness. Unknown to them, across town, a motor plant made a similar calculus, except aluminum windings in a certain product line to hit a price point, bundled with access to a new distribution channel in Africa where aluminum made sense and copper theft was a real problem. The technical compromise rode on top of a commercial offer. The bet wasn't just metal, it was market architecture. And in Africa, capital arrived with a flag. Chinese companies financed and built roads, power lines, and processing plants around Congolese and Zambian copper. Offtake agreements locked flows and equity stakes aligned incentives. Gulf capital followed different flags, similar toolkit. The result is motion. Expanding mines like Kamoa-Kakula, revived assets like Mopani, and a steady push toward local beneficiation. China's fine with that if the acid plants, smelters, or export rails are built with its firms, tied to its service contracts and scheduled to its needs. Critics call this control. Chinese planners call it security. Strategic stockpiles rise when prices wobble. Imports shift in weeks from Chilean concentrate to Congolese or Russian tonnage when tariffs or sanctions bite. Refiners tweak blends to manage impurities, traders arbitrage between exchanges when spreads go wild. If one river is dammed, the water finds another bed, because the channel builder owns the earth movers. Aluminum's parallel bet shows up in policy too. Energy-intensive smelting moves inland when coastal power tightens. Overcapacity gets pruned in one province while another opens a green smelter linked to hydro. Export rebates tilt semis over primary to keep value at home. Standards work quiet, bureaucratic, relentless, nudges global spec toward alloys and profiles Chinese mills are optimized to deliver. Engineers elsewhere call it friction. Procurement calls it inevitability. Meanwhile, the world discovers dependency in stages. A US fabricator realizes its highest-yield copper rod comes from a single Chinese refinery that just went into maintenance. A European busbar maker learns its preferred cathode shape is produced to spec by 2 plants, both behind the same customs line. An Indian smelter fights negative TCRCs and power costs while a new domestic competitor arrives, with Chinese core equipment, offering cathode at a price that assumes scale they don't yet have. The game board tilts toward whoever can run losses to win time. China didn't kill copper. It cornered the steps that turn rocks into circuits, especially refining, where it controls a very large share of global capacity, and paired that with a pragmatic aluminum creep. The point wasn't to remove copper. It was to domesticate it, bind it to logistics, finance, and policy in ways that make substitution a choice China choreographs. If the next decade is about closing a 7 to 9 million ton demand gap, the country that controls the valves and owns a credible substitute in key lanes starts every negotiation with a head start. And here's the quiet part. This strategy only wobbles if others build parallel paths, refining in friendly grids, recycling at industrial quality, standards that don't move with a single committee, aluminum programs matched with training and hardware that keep failures down. Otherwise, the world will keep routing through the same midstream city and paying the toll. The West's playbook specs subsidies speed. While that was tightening in China, something else was brewing in Washington, Brussels, and Ottawa. Policymakers finally read the same charts engineers had been whispering about, a structural copper shortfall colliding with an electrification sprint. The question became blunt. How do you buy time, build capacity, and keep reliability while you wait for geology and permitting to catch up? First lever, specs. Codes are a steering wheel, and when written well, they reduce copper intensity per kilowatt without trading away reliability. If you need less copper per kilowatt without courting failures, you tighten standards where it matters and relax where it doesn't. Utilities revise conductor ampacity tables to favor aluminum in specific feeders, paired with mandated bimetallic hardware, oxide-inhibiting compounds, and periodic retorque intervals that are now enforceable, not best practice. Building codes push copper where terminations are dense, hospitals, high-rises, critical panels, and authorize aluminum feeders in well-defined runs with certified connectors and inspection checklists embedded into commissioning. Procurement rules start to require AL-CU transition kits from approved vendors, not shop floor improvisation. It's substitution by contract language, not vibes. Second lever, subsidies. Smelting and refining aren't venture apps, they're capital hogs with power bills that scare CFOs. Europe and North America dusted off tools used for semiconductors and batteries. Investment tax credits for copper refining and recycling, accelerated depreciation on core equipment, concessional power tariffs tied to emissions performance, and loan guarantees that de-risk first-of-a-kind builds. Logic is simple. Negative treatment and refining charges make expansions irrational. Public money bridges the valley so capacity exists when the deficit bites. In parallel, recycling moves from scrapyards to factories. Grants target high-grade disassembly, EV motors, hairpin stators, busbars paired with black mass-style hydromet lines tuned for copper purity. The goal isn't to replace mines, it's to feed smelters clean, traceable scrap that raises yields and lowers energy per ton. Third lever, speed, permitting timelines kill forecasts. So governments carve critical infrastructure lanes for grid upgrades, refineries, and high-capacity recycling plants, not rubber-stamped shot clocks. One agency leads, clocks start, consultations run in parallel, and missing inputs trigger defaults to keep the calendar honest. Environmental standards don't soften, sequencing does. Early scoping forces projects to front-load water and tailings plans, community benefit agreements, and reclamation bonding, so late-stage lawsuits have less to bite. Regulators get more people, better pay, and digital tools, no more dead files on a desk. Meanwhile, trade policy stops pretending. Copper and downstream semis start getting the semiconductor treatment, carve-outs in free trade talks, stricter rules of origin, and anti-circumvention teams that actually show up. Scrap export controls are calibrated, keep high-grade domestic when refineries are short, but maintain flows to avoid choking processors abroad who feed your own value chains with refined cathode. Stockpile policies leave the theory section. Strategic reserves quietly acquire cathode during dips, then bleed it out to critical projects when spreads blow out. It's not price control, it's shock absorption. All this only works if you fix the workforce. Aluminum deeper into power rooms means different training. Unions and trade schools stand up fast tracks, torque theory for mixed metals, oxide chemistry, inspection by thermography, failure signatures in AL-CU joints. Inspectors get standardized checklists, contractors get certified programs that travel across state lines. For recycling, technicians learn to disassemble EV stators without turning them into mixed scrap, to sort alloys by handheld spectrometers, to run hydromet cells with tight impurity windows. A torque wrench and a fusion splicer live in the same toolkit now, training says so. Then there's friend shoring. If refining is the new choke point, you put it where the grid is clean and the politics are boring. Canada looks like a battery for copper refineries, hydro-rich provinces with existing metals expertise. The US Southeast and Midwest pitch captive power plus logistics. Europe pairs green hydrogen pilots with electrowinning, selling low-carbon cathode to customers who want ESG baked into metal. Contracts knit it together. OEMs commit offtake for years, banks finance against those promises, and public funds take the first loss slice. Design efficiency isn't a press release, it's a requirement. Automakers submit copper intensity plans the way they submit emissions plans, hairpin windings, optimized busbars, higher system voltages that cut current, and thermal designs that keep resistance in check. Utilities adopt loss reduction targets that force conductor choices, transformer specs, and reactive power strategies into a single plan. Data centers commit to busway reuse. modular switchgear, and standard interfaces that let copper move between sites without becoming scrap. Here's the catch: speed without trust backfires. So community deals have to be real, revenue-sharing formulas you can explain at a kitchen table, local hiring quotas backed by training budgets, environmental monitoring dashboards that show tailings pH, water draw, and emissions in public in plain language. Enforcement must bite, miss metrics, lose money. And yes, the West will still buy from Chile, Peru, the DRC, and Zambia. The difference is structure. Equity stakes tied to training and local beneficiation, acid plants and power upgrades financed as part of mine deals, offtakes that include contingency routing, and dispute mechanisms that don't require a crisis to trigger. It's slower than writing a check. It's faster than rebuilding trust after a blockade. Specs, subsidies, speed. It's not elegant. It is a plan. If it lands, copper doesn't stop being scarce. It stops being the single point of failure that decides whether an EV line idles or a hospital wing goes dark on a hot night. Copper kingdoms on the edge. 3 days earlier in Santiago, a minister stared at a water map, not a price chart. Desalination lines zigzagged up from the Pacific like surgical tubing, feeding mines that once drank rivers now running at a trickle. Chile still sits on the crown, porphyries the size of cities, but the crown is heavy. Grades are thinner, pits deeper, power pricier, and every 0.1% less copper in the rock adds trucks, tailings, and tension. Investors see reserves, communities see dust and diesel. The bargain that built Santiago's skyline is fraying at the edges, one drought-scarred season at a time. While that was happening in Chile, Peru's calendar slipped for a different reason. A single road blockade in the highlands can sideline a quarter of exports within days. Camp kitchens go quiet, concentrate trucks line up like a stalled river, and the cash flow that pays for clinics and roads pauses mid-sentence. Companies renegotiate community agreements as often as they tweak mine plans. The ore is excellent. The timeline is fragile. In Lima, officials promise streamlining. In the Andes, leaders ask what benefit sharing looks like after the ribbon-cutting crew leaves. Unknown to them across Africa, a different clock was speeding up. The DRC's copper belt, long a synonym for potential, is now a production machine. Kamoa-Kakula keeps adding phases like a metronome. New acid plants and power lines shadow the expansions. Zambia, stung by lost years, is back on the field. Mopani recapitalized with new investment. Konkola copper mines revived, and new projects pulling permits faster than old stereotypes say is possible. But the constraint isn't always the pit. It's the road, the rail, the border queue. A storm in the Zambezi corridor or a strike at a port can erase a quarterly forecast, and a new political mood hangs in the air, value addition at home, or the truck doesn't roll. In Beijing, planners don't wait for memos. When tariffs twist trade, cargoes pivot mid-ocean. 1 week Chilean concentrate, the next Congolese tonnage, the next Russian material blended to keep impurities inside a refinery's comfort zone. Refineries absorb the shock because the cluster power, acid, labor, logistics was built for exactly this. Treatment and refining charges can compress sharply and they'll still run because the metal feeds factories that can't blink. If you sell rod and wire to half the world, you defend the midstream like a border. Meanwhile, in New Delhi, the calculation is more precarious. India can dig but not at scale yet. It can smelt but margins are knife-thin when TCRCs collapse and power costs bite. Domestic demand is climbing toward millions of tons. One coastal smelter went dark years ago, a new one just lit its first anodes. Policymakers juggle levers, duty tweaks on cathode and rod, production-linked incentives, GST rationalization, quality control orders, trying to grow midstream muscle without triggering price spikes that stall infrastructure plans. A refinery needs cheap, clean power and a decade of certainty. India has the engineers, it's racing the calendar. In Lusaka, a finance minister asks a simple question with hard edges. Why ship value? Refined cathode earns more than concentrate. Wire rod plants create jobs, not just royalties. Zambia and the DRC push beneficiation mandates, offer tax holidays for smelters, and talk rail corridors the way others talk startups. Gulf and Chinese capitals step in with cash and crews. Western miners ask for stability that outlasts one election. The answer to both is the same. Build power and trust first, then stack value on top. The risk is pace. Move too slow and the deficit widens elsewhere. Move too fast and a smelter starves when a mine hiccups. Europe reads the room differently. Its grids need metal, its voters want low-carbon everything, and its legacy smelters choke on power bills and regulations written for a different century. Brussels drafts critical raw materials measures, considers export controls on high-grade scrap to feed domestic recyclers, and dangles subsidies for green refining that runs on hydro or nuclear. A refinery permit can still take years, but a new word appears in the footnotes: urgency. If strategic autonomy means anything, copper has to be in the sentence. Washington writes in a similar pen. Tariffs come with friendshoring speeches. Agencies pilot shot clocks for grid expansions and recycling plants. Stockpile policy inches from white paper to purchase order, and copper starts appearing alongside oil in strategic planning. The aim isn't autarky. It's optionality. If one port snarls, if one country changes the tax code mid-contract, if one refinery cluster goes offline, there should be another path to the same busbar. Here's the truth the charts don't show. Copper kingdoms are not just deposits or refineries, they're systems of trust. Chile's trust rests on water and fairness. Peru's on consent that doesn't expire when a convoy leaves. The copper belt's on rails that run and contracts that don't move with the wind. China's on a promise that midstream muscle won't be weaponized beyond the accepted rules of the game. India's on policy consistency, cheap electrons, and a scrap market that turns informal hustle into industrial feedstock. Europe's on paying to keep metal making inside a clean grid. America's on speed that doesn't skip the community meeting. All of them are on the edge for the same reason. The load is rising faster than institutions were built to carry. The geology is there. The question is whether the bargains that made yesterday's copper maps can be renewed, fast, fair, and at the scale a hotter, more electric decade demands. Desperate pivots and new dependencies. From their perspective, the only sin is missing the deadline. A utility CFO sees copper quotes jump and signs off on aluminum feeders with bimetal pads just this once. An automaker trims copper in motors and pushes hairpin tolerances a notch tighter. A data center rewrites a spec to accept a different busway profile because the original vendor missed a shipment. Each is reasonable. Together, they're a drift toward materials and suppliers that weren't on the map 5 years ago. Here's where the pivot gets sticky. When you substitute under pressure, you don't just switch metals, you switch ecosystems. The aluminum feeder comes bundled with proprietary lugs, paste, and a torque spec that only one training course really covers. Miss it and maintenance becomes a coin flip in a heat wave. The hairpin redesign relies on a varnish chemistry from a single supplier 2 oceans away. That supplier hiccups, and an entire EV line rewrites its charge curve to keep connectors alive. The data center busway now uses a jointing system only one service team supports. They're great, until a storm strands them on the wrong side of a closed highway. Then there's the geographic dependency. In the scramble to secure cathode, buyers discover their lowest loss rod comes from 2 refineries behind the same customs regime. A tariff volley lands and their premium doubles overnight. They pivot to billet from a friendshored plant in a region with fragile power, discover blackouts aren't hypothetical, and watch lead times slip. The next call is to a trader who can reroute metal mid-ocean at a price that turns a project budget into a hope. Meanwhile, processors feel the squeeze from the other side. Treatment and refining charges thin to razor levels, some contracts even flirt with negative. The rational response is to delay maintenance. The consequence is unplanned downtime at the exact moment demand is least forgiving. A refiner in one country pauses an acid plant, a heap leach 1,000 miles away starves. A smelter pushes a campaign longer than comfort allows, an outage ripples through rod mills that assumed steady feed. None of this looks like collapse. It looks like Friday afternoon emails that start with regret to inform. Policy complicates the detour math. Export rules on high-grade scrap tighten in one block to feed domestic recyclers. Processors elsewhere lose the clean input that made their impurity balance work. The alternative is low-grade scrap with headaches baked in lead, zinc, and mystery metals that chew up yields and ESG scores. Buyers layer on traceability requirements. Informal recycling routes that everyone used to pretend not to see suddenly block your product from a market. The pivot you thought solved a price problem creates a compliance problem. Investors, for their part, chase speed. Capital runs to jurisdictions that promise shot clock permits and cheap, clean power. That brings new refineries to grids that can handle them and to some that can't. A project pencils at hydro prices, a drought pushes power onto gas, carbon intensity jumps, the off-taker's green metal covenant snaps tight. The refinery is fine technically. Commercially, it just lost its biggest customer. There's also the quiet bet on single vendor technology. A wave of new smelters and refineries comes kitted with equipment from the same 2 OEM stacks. It's sensible, proven gear, service networks, spares. It's fragile if geopolitical weather turns. Sanctions or export controls can turn a maintenance cycle into a scavenger hunt. A plant doesn't fail because a furnace cracks. It fails because a PLC card stays in customs for 6 weeks. On the automotive side, copper diets push designs toward higher system voltages to cut current, 800 volts where 400 once lived for many platforms. That trims cross-sections and heat, but it also ratchets insulation and creepage demands. One supplier change on a busbar laminate adds a failure mode that only reveals itself after a summer of supercharging. Field fixes are precise, but they burn time and trust. The pivot bought kilograms, it sold margins. And in grids, aluminum creeps closer to the wall. The mitigations we know, AL-CU lugs, oxide paste, retorque intervals, become line items in maintenance budgets that were already thin. Inspectors add thermography routes, contractors add certifications. It all works until turnover hits, a crew rotates, and a checklist becomes lore instead of law. Copper forgave those moments. Aluminum keeps score. Geopolitics keeps writing footnotes. Tariffs swing, and copper that once flowed through one hub detours through ports with less storage and slower cranes. Strategic stockpiles buy metal into dips, then release into projects with political priority. If you're not on that list, your shipment moves a week. That week cancels a test. That canceled test moves a hospital opening. So the desperate pivots are rational. They buy time. They also buy dependencies we don't price well, training that must stick, vendors that must stay solvent, ports that must stay open, policies that must stay in one piece through an election. The way out isn't to ban substitutions. It's to pair every pivot with ballast, standards that travel across borders, second source vendors in boring places, stock that lives closer to where it's needed, and maintenance that's treated like generation, not overhead. Because this is the point, the transition will keep moving. The question is whether the shortcuts we take today become the fault lines we regret tomorrow. Inside utility math, total cost, total risk. From their perspective, copper isn't a line item, it's a risk profile. A utility planner sits with 3 columns on a whiteboard: CapEx, OpEx, and outage. The first 2 are accounting. The third is the one that ends careers. Start with a feeder upgrade. Copper conductors means smaller gauge, fewer towers for the same ampacity, tighter losses. Aluminum wins weight and upfront cost, but it buys sag, fatter profiles, and heat you carry in peak season. On paper, you normalize by ampacity and note the savings. In the field, you price the wind, the sun, and the wrench. Galloping risk in winter, thermal expansion in summer, and the certainty that one lug torqued wrong becomes a hotspot in August. Now fold in losses. Every megawatt lost as heat rides a fuel price and a regulatory penalty. Copper shaves resistive losses, which look small on a spreadsheet until you multiply by 25 years in a wholesale price curve. Aluminum requires upsizing to match, plus hardware that mitigates joint resistance. The total loss line looks like decimals until a heat dome lands. Then the board asks why SAIDI and SAIFI spiked when the forecast said manageable. Meanwhile, reliability isn't a binary. It's a stack: conductor, connector, splice, termination, inspection, and the crew that drew the night shift. Copper makes that stack thicker, more forgiving of a missed retorque, a nicked strand, a lug that saw dust. Aluminum narrows the cushion. So the planner assigns a probability to failure per 1,000 joints, a mean time to repair, and a customer minute penalty. Multiply by thousands of joints across a district, and the cheap option acquires a tail that wags the dog. Then there's construction tempo. Copper's smaller gauge pulls faster through crowded ducts, elbows clear with less persuasion, cable trays carry more capacity per slot. Aluminum upsize fights bends and tray fill. You can pay in larger conduits, extra pulls, or more crews. In a labor market already stretched, schedule slippage costs real money. Miss an outage window and you're renting diesels to hold a hospital's load while you finish a tie-in that should have cleared yesterday. The invoice says fuel. The subtext says planning. Substations are their own calculus. Bus bars in copper mean compact gear, less thermal drift, and simpler joints. Aluminum bus saves capex if you standardize on bimetal pads, oxide paste, and calibrated torque tools. The math works if training sticks. If it doesn't, thermography routes light up like Christmas, and every red tile on a dashboard is a future Saturday with double-time pay. You can budget for paste and pads, you can't budget for turnover. Now widen the frame to procurement risk. Copper price volatility feeds bids, aluminum has its own swings tied to power markets. Cathode tightness lengthens lead times on copper busway, smelter maintenance stretches aluminum profiles. Tariffs flip premiums in a week. The planner's mitigation looks boring: multi-year offtakes, dual-spec designs that accept either metal with certified hardware, and buffer inventory on critical connectors. Finance calls it working capital. Operations calls it sleeping at night. Losses in the network feed into rate cases. Regulators scrutinize line loss improvements and heat events. A copper-heavy design gives you a baseline you can defend: lower ITWAR losses, fewer hot joints, stable maintenance intervals. Aluminum-heavy designs require the package: hardware spec, inspection cadence, and training records. You can win the case with either if your data is good and your incidents are low. Miss one summer and the same plan looks reckless. Then there's growth you didn't plan for. Data centers land like small cities, asking for 100 MW and redundancy yesterday. EV fast charger corridors load feeders that were comfortable last year. The contingency line on your one-line diagram becomes tomorrow's base load. Copper buys you margin, aluminum buys you speed and available budget. The compromise most planners choose: copper where terminations are dense and access is limited, aluminum on long, well-monitored runs with standardized joints and strict commissioning. It's a choreography, not a bet. Recycling enters quietly. Secondary copper and aluminum reduce embodied energy, which regulators and investors now count. But secondary quality varies. A bad scrap blend can turn one batch of connectors into a maintenance letter. So the planner leans on suppliers with traceable scrap streams and lock spec to certs that survive audits. ESG isn't PR, it's procurement risk with a different logo. Finally, outage math. A blown joint on a commuter corridor at 5 p.m. costs millions in customer minutes, fines, and headlines. A planned upgrade that drifts 2 weeks because a shipment slipped costs reputation you'll spend all winter to regain. The model weights those tails heavier than CapEx deltas. That's why the cheapest BOM rarely wins alone. The least regret design wins: paired metals, known hardware, training you can enforce, inventories that live in the district, and vendors who answer phones at 3 a.m. Get this, the utility isn't choosing metals, it's choosing failure modes. Copper-S are fewer and slower. Aluminums are manageable, but they demand discipline that doesn't flinch under heat, turnover, or election cycles. The total cost isn't today's bid, it's 25 summers without a headline. Telco and hyperscaler economics. From their perspective, bandwidth isn't a product, it's a liability until it's sold twice. Telcos build the pipes and then pray utilization rises fast enough to outrun CapEx. Hyperscalers invert it, they manufacture demand, AI, video, cloud, and then race their own build plans to keep latency promises. Both stare at the same spreadsheet constraint. Every marginal gigabit rests on glass that drinks electrons and rooms that run on copper. Start at the edge. A national carrier weighs 5G densification against fiber backhaul. Radios are commodity, the real bill is trenching and rights of way. Fiber strands are cheap, permits are, so they lay far more glass than they need on day one, light what revenue justifies, and lease dark strands to rivals. That lease is the first sale. The second sale is the service on top, SLAs with penalties that make CFOs twitch. Miss latency by a handful of milliseconds, and you're paying for trucks on a Sunday. Meanwhile, hyperscalers buy time in bigger blocks. They don't argue about fiber, they pre-purchase routes, whole conduits, and future capacity with take or pay clauses. DWDM gear turns one strand into many, but every color you light requires transceivers, amps, and cooling. The electric bill doubles back into network planning. A petabit across a region forces substation upgrades. Substation upgrades force choices between copper bus and aluminum busway that ripple into uptime math. A 1 in 1,000 failure on a bimetal pad is unacceptable when a single campus serves 1 million users. Here's where the economics bite. Telcos carry legacy copper they can't rip out profitably, old pair gain systems, rural plant with decades of life left. Fiber to the home pencils in dense zip codes, out on county roads, copper DSL hangs on because trenching costs devour returns. So they play hybrids, fiber from the code to the curb, coax or copper the last stretch, and a calendar that assumes a regulator won't force an upgrade faster than cash flows allow. Every quarter they defer the copper funeral buys, another quarter of spectrum auctions and debt service. Hyperscalers have their own hybrid, short copper inside the racks for direct attach links, glass between rows, glass between buildings, and glass between regions. But power is copper all the way down. New AI halls flip from 30 MW projections to 100 MW realities. That jump turns speculative grid talk into binding commitments. Dual feeds, ring substations, harmonic filters, and switchgear that shows up complete or pushes a launch. They'll take aluminum bus in the yard if training and thermography are bulletproof. In the white space, copper wins because service windows don't exist once customers move in. Both sets of planners play the same risk games. Material hedges show up as multi-year contracts for optical modules and copper busbars. When tariffs choked transceiver imports, one hyperscaler rewired its BOM to accept modules from 3 vendors, different pinouts, different power profiles, then paid the tax in inventory and firmware teams who made it work. A telco did the mirror image with copper, dual-spec feeders AL or CU with certified lugs and pre-approved inspection routines. Not elegant, very survivable. Subsea makes the math cinematic. A single transoceanic cable costs billions. Capacity is sliced into indefeasible rights of use, IRUs booked like mortgages. Hyperscalers pre-buy decades to own latency between their regions, telcos buy slices to resell. The construction timeline is physics and paperwork, shipyards for repeaters, landing permits in multiple countries, and armoring for the shelf where anchors roam. Copper barely appears in the cable, it dominates the landing stations, rectifiers, battery rooms, bus bars, switchgear. A storm at sea can cut the fiber, a heat wave ashore can trip the power that feeds the lasers. Both failures look the same to a user, the spinner of death. Then there's churn nobody priced, AI's appetite. Model sizes leapfrog every 9 months. East-west traffic inside a campus explodes, north-south to other regions doubles back. Hyperscalers overbuild inter-region glass, then discover their real bottleneck is inside the fence, top of rack to spine, spine to core, leaf to leaf. Copper TwinX reaches run hot at 100G, 400G, optics creep inward, dragging their power demand with them. The more photons you push, the more copper you commit to feeding the boxes that light them. Telcos respond with old tools sharpened. peering agreements to keep hot paths local, content caches at cell sites, fiber rings with automatic protection switching that fail over without a human noticing. Each improvement pushes more critical gear to the edge, and every edge build is a miniature utility project. Pad mount transformers, ALCU transitions, ground grids that pass muster during a lightning storm. No one budgets for a truck roll because a lug breathed under August load. They budget for insurance that prevents it. Supply risk is now a line item. Chinese refining concentration for copper and module manufacturing concentration for optics create mirror dependencies. A tariff volley moves copper premiums. An export license rule strands optics. Hyperscalers answer with friend-shored refineries in hydro grids and second-source optics in Mexico or Eastern Europe. Telcos answer with vendor diversity and country of origin clauses that lawyers can actually enforce. Both stockpile the weird things. Spare busway elbows, 400G ZR Plus modules, ALCU pads that fit last year's switchgear. The human part doesn't go away. A fiber splice tech learns to clean ferrules like a lab tech. An electrical foreman learns to read a thermography report like a radiologist. Contracts now specify torque curves, not just torque values, and mean time between failure for modules alongside packet loss SLAs. It's all one system: photons for distance, copper for certainty, and accountants for the permission to build both before the revenue curve arrives. In the end, telcos sell confidence at street level. Hyperscalers sell confidence at cloud scale. The economics say glass wherever a meter is expensive and copper wherever a minute is, while remembering that each new optical watt drags power upgrades behind it. Everything else is choreography of permits, ports, power, and patience, priced by the cost of a missed millisecond on a day when the world is watching. The 1970s lesson fixed quietly. 3 days earlier, an engineer in a gray archive room rolled out a brittle blueprint from 1974. It showed something most of us forgot. The last time copper felt scarce, we didn't issue press conferences, we changed parts. The 1970s crunch wasn't just oil lines and odd-even plates, it was copper lines too. Prices spiked. Builders panicked. Utilities stared at reels they couldn't afford. The fix arrived in a whisper: aluminum. Back then, substitution wasn't a vibe, it was a necessity. Utilities swapped copper feeders for aluminum on overhead lines, then crept into substations and service entrances. Appliance makers experimented with aluminum windings. Telcos stayed with copper for voice through that era, but power folks moved because aluminum was light, available, and cheap. The first wave went fast, too fast, and the metal taught everyone a blunt lesson. Aluminum conducts well, but it keeps score on joints. What nobody knew at the time was how punishing those early mistakes would be. Lugs designed for copper got reused on aluminum, oxide layers formed, torque drifted, joints heated, and house fires made headlines. Codes stiffened. UL listings tightened. Electricians learned new words: bimetal, oxide-inhibiting compound, cold flow. The industry did what it always does under pressure. It wrote the pain into standards, tools, and training. Then the quiet fix happened. Hardware caught up. Connectors gained serrations and platings that bit through oxide and stayed put. Torque specs went from folklore to label. Inspectors added retorque intervals. Thermography found hotspots before smoke did. By the late 80s, aluminum in feeders and bus had matured from risky shortcut to normal engineering as long as you did the work. Copper never left the room, it just ceded lanes to a metal that demanded discipline. Meanwhile, another fix arrived on a different map: fiber. The same decade that taught utilities to spec aluminum taught telcos to dream in glass. Long-haul microwave and coax made do until the first optical systems proved distance could be cheap if you spent on endpoints. Throughout the 80s and 90s, fiber quietly relieved copper of data duty, just as aluminum relieved it of some power duty. The pattern is the part that matters. Scarcity drives substitution, substitution fails loudly, standards absorb the blood, and a new normal settles in. That's the template on the table now, only busier. Today's swap isn't 1-for-1. It's aluminum deeper in grids, fiber everywhere for data, higher voltage EV systems to cut copper mass, and recycling moving from scrapyards to factories. The lesson from the 70s isn't that aluminum saved us, it's that aluminum paired with rules, hardware, and training saved us. The metal didn't change, we did. There's a micro story that makes it plain. A Midwestern utility that lived through the 70s still keeps a wall of failed connectors, charred lugs, split barrels, melted pads. Every apprentice walks past them before touching a wrench. Their current spec reads like a memory palace. ALCU pads only, oxide compound brands specified, torque curves by size, mandatory retorque at 90 days, thermography annually, crew certification renewals every 2 years. Their outage stats are boring. Boring is how you wins. Policy learned too. Code councils moved from debating metals to mandating practices. Aluminum allowed became aluminum allowed if listed hardware, if trained crews, if inspection windows that someone is paid to honor. Insurers got into the act, pricing premiums against proof of maintenance. Banks underwrote projects with covenants that made retorque a line item as real as debt service. The fix embedded itself in money. On the supply side, manufacturers pivoted. Connector companies built entire product lines around AL-CU interfaces. Transformer makers standardized aluminum windings in tiers where losses still passed the math. Busway makers sold dual families, copper for dense terminations, aluminum for long runs paired with training that traveled. The market stopped arguing theology and started selling kits. If you listen closely, you can hear the same tone today in different nouns. EVs are the aluminum of this era's mobility, right in principle, messy in practice until specs, parts, and people catch up. Each EV still uses multiples of the copper found in an internal combustion car, making copper a gating factor for scaling. Fiber to everything is the optical replay of long-haul fiber, obvious now, fragile at the edge until cleaning, splicing, and documentation become muscle memory in every crew. Copper recycling is the standards problem reborn. Secondary metal is fine if purity is traced, chemistry is controlled, and informal shortcuts are dragged into daylight. And then there's trust. The 70s swap only stuck when homeowners, inspectors, and utilities believed the fix would hold. Not because someone said so, but because years passed without smoke. Today's public will grant fewer second chances. So the quiet fix has to be loud in its transparency, dashboards that show maintenance hits, audits that survive a court, warranties that bite if the paste can was left unopened. Get this, the 197s didn't teach us that copper is replaceable. They taught us that copper is negotiable if you respect failure modes and pay the maintenance you promised. That's the lesson being reissued now at higher speed and larger scale. We don't need a miracle metal. We need the same unglamorous choreography, better parts, trained hands, honest schedules, and the humility to revisit a torque spec because August reminded you who's in charge. The fix will look boring when it works. It should. The headlines will focus on new mines and big subsidies. The backbone will be the checklists that move copper out of places it doesn't have to be without moving risk in. That's how the last crunch ended. That's how this one avoids becoming a crisis we pretend we couldn't see coming. Energy, emissions, and the smelter equation. From their perspective, copper isn't just metal, it's megawatts. A smelter is a power contract wearing a hard hat, and the midstream's choke point is often a substation, not a furnace. Energy defines margins, emissions define permission. Put those together and the question gets sharp. Where do you add refining without blowing the carbon math or the balance sheet? Here's the baseline. Primary copper takes serious energy, secondary copper takes far less but demands clean, traceable scrap. Smelters cluster where electrons are cheap and steady. That's why China held the gravity well, integrated power, acid, labor, logistics, so even when treatment and refining charges went thin or negative, plants kept running. Elsewhere, power spikes turned feasibility studies into doorstops. So the new builds chase green electrons. Hydro grids in Canada, geothermal hydro mixes in Chile, hydropower in Zambia, each turns a carbon liability into an export pitch. Low CO2 cathode you can put in an ESG report. Europe flirts with green hydrogen pilots for electro-winning, pairing subsidies with clean power to keep metal making inside its borders. The US and India talk concessional tariffs tied to emissions performance, cheap power if you meet a carbon curve that tightens every year. Recycling is the multiplier. Industrial-grade dismantling of motors, hairpin stators, and busbars feeds hydromet lines tuned for purity, cutting energy per ton and emissions per invoice. But impurities and informal scrap can wreck both. The fix is boring and brutal. Certification, chain of custody, and buyers who reject mystery metal even when prices scream. In the end, the smelter equation is simple. Electrons, permits, people, and proof. Signals in the noise, markets, and motions. From their perspective, a price chart isn't a prediction, it's a diary of decisions. Copper didn't drift up on sentiment, it climbed on signposts and missed shipments. You can see it in the spreads. One quarter, the CME outruns the LME by a mile, a 3-digit premium that says US buyers are raiding every warehouse they can reach. A tariff headline drops, the spread snaps back, and traders spend a week unwinding cargoes rerouted mid-ocean. That volatility isn't just a trade. It's a map of where fear is. Treatment and refining charges tell the same story in a different dialect. When TCRCs compress to razor levels, sometimes even dip below zero, the message is blunt. There's more concentrate chasing, not enough refining than the other way around. In a normal cycle, smelters use fat TCRCs to fund maintenance and expansions. In this one, thin margins trigger deferred turnarounds and shelved debottlenecks, exactly when policymakers are begging for new cathode. Negative TCRCs aren't a curiosity, they're a warning light. Watch scrap, high-grade flows are the pressure valve for refineries. When those streams tighten, premiums climb and purity headaches multiply. Europe considers rules to keep recyclable metals onshore to feed circular economy goals. That sounds tidy in a memo. Downstream, it yanks clean feedstock from processors in other regions who were counting on it to balance impurities. Meanwhile, some countries export the good scrap and import low-grade back because the short-term arbitrage pays. Refiners eat the chemistry and the PR. Stockpiles used to be a trivia question. Now they're policy. Exchange inventories jump from rounding error to headlines as smelters and state buyers quietly build buffers on dips. China's LME-registered copper rises in weeks. Elsewhere, strategic programs test copper the way they once tested oil. Buy small, release smaller. Watch the effect on confidence more than price. It's not intervention so much as a metronome in a market that keeps changing tempo. Listen to offtakes. OEMs that treated copper like a commodity now ink multi-year agreements with miners and refiners, sometimes three-way deals that stitch rock to rod to wire. The contracts read like risk registers, impurity windows, ESG attestations, penalty schedules, and fallback sources you hope you never use. A decade ago, that language lived in battery metals. Now it lives in copper because lead times stretched, and nobody wants to discover what a line stop costs when a cathode doesn't arrive. Africa's motion shows up as capex, not optimism. In the DRC and Zambia, expansions at Kamoa-Kakula, fresh cash into Mopani and Konkola, acid plants coming online in lockstep with leach expansions, these are real moves. Gulf and Chinese capital write big checks. Western miners add offtakes and minority stakes to diversify away from single-country risk. Rail concessions and power lines get announced as often as pits. The signal is simple. Geology isn't the bottleneck. Logistics is, and money is finally chasing the right choke points. In Latin America, the signals are calendars. In Chile, desal pipelines get longer, power contracts get greener, and costs creep because grades slide. Projects clear one permit and wait on another, pushing first metal dates out by quarters that add up to years. In Peru, community agreements and road access are the line items that move share prices on a Tuesday afternoon. When a blockade lifts, export data spikes. When it returns, analysts redraw production curves without fanfare. These aren't surprises anymore, they're rhythms. Policy shows up in premiums. 1 week, export controls on high-grade scrap in Europe tighten physical markets. The next, U.S. tariffs tweak differentials and pull metal across basins at odd angles. Buyers in Southeast Asia see cathode offers tied to a specific refinery's maintenance calendar. Buyers in India juggle quality control orders and GST quirks that change the landed cost of rod by points that make or break a quarter. The price you pay isn't the headline. It's the sum of all the footnotes. Recycling's maturation has a tell. Banks underwriting projects that look more like factories than scrapyards. Grants and loans hit high-purity disassembly lines for EV motors and industrial gear, hydromet circuits tuned for copper that can feed primary smelters without wrecking their impurity balance. The KPI isn't tonnage, it's assay. Buyers are starting to reject mystery metal even when the price is right because traceability is now a condition of sale, not a brochure line. Design efficiency isn't a press release, it's BOMs that shave kilograms. Automakers publish copper intensity targets the way they used to publish fleet MPG, and suppliers respond with hairpin windings, bus bars that carry more with less, and 800-volt platforms that cut current. Utilities file loss reduction plans that quietly lock in conductor choices, transformer specs, and reactive power strategies. The market hears it in less copper per kilowatt, and more orders for the hardware that makes that safe. Watch the workforce. Certifications for ALCU joints, torque auditing, thermography routes, and EV stator disassembly are appearing in union halls and trade schools. Inspectors now carry handheld spectrometers and IR cameras as standard kit. When maintenance becomes a credentialed craft with testing and renewals, you know substitution is moving from allowed to expected. The people signal is loud when the metal signal is quiet. Financing is a signal too. Investment tax credits and green power tariffs tip copper refining projects from the someday stack to the board agenda stack. Loan guarantees shave risk for first-of-kind recycling plants. Offtake-backed project finance shows up in places with hydropower and boring politics. If a refinery proposal comes bundled with a decade of clean electrons and a long-line offtake, it moves. If it comes with hope and a peak-hour tariff, it stalls. And then there's the whisper network. Maintenance cycles extended a few weeks beyond comfort, an acid plant paused that starves a leach pad, a shipment resold at sea because a premium moved. Those aren't crises. They're the jitter you see when a system is tight. Procurement teams respond with second sources, dual specs, and inventory that lives nearer to the job. It's expensive until the day it is. Here's the thread through all of it. The loud signals, price spikes, tariff headlines get the clicks. The true signals live in contracts, calendars, and checklists. Compressed TCRCs, longer offtakes, stockpiles that rise on Tuesday and fall on Friday, certification programs that didn't exist a year ago, and capex that follows rails and power as much as ore. Markets don't shout shortage. They whisper schedule. If you read the noise right now, it says the same thing your foreman says before a heat wave. Tighten the lugs, check the joints, and don't believe the estimate that hasn't been stress tested. Micro stories from the front lines. The call came at 3:12 a.m. A maintenance supervisor in Phoenix stared at a thermal image that looked like a campfire where a lug should have been cool blue. One ALCU joint on a hospital feeder was glowing. He had 40 minutes before the ICU flipped to backup. Two techs rolled with a torque wrench, oxide paste, and a replacement pad. In the cramped mezzanine, they loosened, cleaned, repasted, retorqued twice, then watched the colors drift from orange to green. The nurse manager sent a text that just said, "Thanks." Nobody tweeted it. On the whiteboard, the supervisor wrote one line, "Training held." 3 days earlier in Gujarat, an operations manager walked the new tank house aisle listening to a rhythm only he hears, anodes lowering, bubbles at the surface, the faint hiss of air. The first month's cathode was in spec, but barely. Power prices spiked in the afternoon, and he'd been nudging current density to keep the bill sane without throwing impurities out of range. On his desk sat a spreadsheet that could make the plant profitable or not depending on a number with 2 decimals, TCRCs. If they dipped again, he'd push maintenance a week. He hated that thought. He looked up at a crew chief checking a busbar connection with a torque meter and felt a small slice of relief. If you can't fix the market, fix the joints. In a high-rise in Madrid, a project engineer stared at a shipment notice that had one missing item, the copper busway elbows. Without them, a hotel opening sat on a calendar like a dare. The supplier blamed a refinery outage, the refinery blamed a tariff, the tariff blamed a headline. The engineer's phone buzzed. An alternate vendor could ship aluminum elbows if the building inspector signed off on the revised spec, pads, and inspection plan. She spent the afternoon in a conference room with a city inspector, a contractor, and a lawyer rewriting a construction detail into a maintenance program. Torque curves, thermography routes, a 90-day retorque window, and who pays if it slips. The elbows arrived 2 days later. The opening did too. On a dusty shoulder outside Kalwizi, a driver killed the engine and climbed onto his concentrate truck. The line of trucks ahead of him snaked toward the border like a slow metal river. A storm had washed out a culvert 30 kilometers ahead. Road crews were patching it with whatever they could haul. He did the math on his per diem, the bribe he wouldn't pay, and the call he'd make to tell his sister his remittance would be late. Downstream, a smelter scheduler in Shandong moved his name from Monday to Thursday, increased the ratio of a cleaner concentrate to keep arsenic in spec, and sent an apology to a rod mill that would now get cathode on Friday, not Wednesday. None of them knew each other. All of them carried the same delay. At a suburban utility yard in Ohio, a foreman taped a photo to the corkboard, a charred connector pulled from a feeder last summer. It sat beside a list of names, everyone due for recertification on AL-CU terminations. He'd lobbied for the class to be mandatory. He still remembered 1979 as a rookie, the smell of a burned lug in a strip mall that should have been fine. The younger techs rolled their eyes at his stories until August came, the heat rose, and thermography walks started lighting up the map. Then they showed up early, coffee in hand, ready to talk torque. In a Frankfurt office, a procurement director watched the CME-LME spread blow out on her screen and felt her stomach do the same. The US premium had jumped again. Her plant didn't ship to America, but her suppliers did. She called a trader, rolled a tranche to a different delivery point, and signed a 6-month cathode contract that cost more than she liked and less than she feared. Before she hung up, she added one clause: second source refinery, EU origin preferred, maintenance schedules disclosed quarterly. The trader sighed and said, "Everyone's asking for that." She replied, "Everyone's late asking." In a lab in Shenzhen, a motor design team pushed a hairpin winding a little too hard on a Tuesday and spent the next week unwinding it. The varnish that kept a new aluminum leaning copper design in line wasn't playing nice with a supplier's updated solvent. At 800 volts, a blister became a failure signature. They caught it in testing, the field never saw it. 2 days later, a quality engineer drafted a change. Supplier QA must disclose formulation shifts 90 days ahead. The supplier balked. The OEM held the line. Copper diets are fine, the lead engineer said, but only if the chemistry doesn't move in the dark. On the edge of Winnipeg, a crew from a cable plant loaded pallets of aluminum alloy conductors bound for a utility in a copper theft-plagued district. The order came with an unusual line item. The service team would train the client's field crews on installation and leave behind torque tools set to the exact spec. They de-learned the hard way a year earlier: great product, bad joints, angry calls. This time, the sales pitch included a day with wrenches and paste. The plant manager watched the truck roll and thought how odd it was that their biggest competitive advantage wasn't a metal. It was a class. At a port in Mombasa, a shipment of high-grade scrap sat in a shed while a new export control rule ricocheted through an agency that had never seen one. Paperwork that used to take hours took days. By the time the container cleared, the buyer had found another source. The seller called a recycler in Bavaria, apologized, and lost the next deal. That same week in Antwerp, a refiner rejected a load of low-grade scrap that had slipped through a different port with the right codes and the wrong chemistry. Traceability went from brochure to gatekeeper. A week later, a grant landed for a disassembly line that would turn motors into clean feed. The recycler posted a job ad for technicians who could use spectrometers. The old yard dog who'd sorted by sight for 30 years walked over and signed up too. In a Calgary control room, a Hyperscalers power engineer watched a dashboard during a heat wave like it was a heart monitor. Red tiles meant heat on a busway joint, amber meant a warning. The building had gone aluminum in the yard to meet a schedule. Inside, copper fed the racks. A joint flashed amber. He pulled up the crew roster, saw the tech on duty had just passed the new ALCU certification, and exhaled. The tile faded back to green after a scheduled retorque. He sent a thank you note to the training contractor. It felt silly. It was. A week later in Santiago, a community liaison officer stood under a tent with a microphone that squealed and a map of a desalination pipeline pinned to a foam board. She'd grown up in the district. Her uncle had worked at the mine in the 90s. The crowd wanted to know what benefit sharing meant now that the river's flow had a new competitor. She pointed to a line item that mattered more than any PR line, a revenue share formula tied to verified outputs, public water monitoring dashboards, and a schedule of payments that didn't move with government changes. A farmer asked a simple question, and if they miss, she answered just as simply, then money stops and my job ends. The room went quiet enough to hear a generator in the distance. In a Bengaluru boardroom, a CFO flipped a slide that showed copper demand curves crossing domestic smelting capacity like scissors. The next slide showed GST leakage in scrap flows, quality control orders that pinch small manufacturers, and a duty tweak proposal that would keep cathode affordable for downstream without strangling a new smelter. The board didn't argue the need. They argued the calendar, how to grow midstream muscle fast enough to keep EV plants, cable factories, and data centers from rationing by price. The CFO ended with a sentence nobody liked but everyone accepted. We either plan the subsidies or we pay them later in outages. The small shop in Detroit, a master electrician unpacked a carton of ALCU lugs for a retrofit and handed a torque wrench to an apprentice who'd only ever used an impact. This is slower, the apprentice said. The master nodded. It's also how you don't get a call at 2 a.m. He pointed at a laminated card with torque values and a QR code to the manufacturer's video. The apprentice scanned it, watched in silence, then asked if he could keep the card. You'll get your own, the master said. After you prove you don't forget. And on a gray morning in London, a fund manager stared at a map with pins in Chile, Peru, the DRC, Zambia, Quebec, and Gujarat. Each pin had a note: water, roads, permits, power, training. He'd spent a decade scoffing at ESG as marketing. Now he priced it as risk. He shifted a chunk of capital from a glossy exploration deck to an unglamorous recycling plant with a signed offtake and a hydro contract. It wouldn't make a headline. It would make copper quietly, cleanly, predictably. He sent the order, closed his laptop, and walked to a meeting where someone would ask about thematic exposure. He'd say one word: reliability. Then he'd tell the story of a hospital lug at 3:12 a.m. and the two techs who kept it cool. The quiet doctrine: control beats conductivity. From their perspective, the winning metal isn't the best conductor. It's the one that shows up on time with paperwork that survives an audit. This is the quiet doctrine that's been forming beneath the headlines. Control outruns conductivity. The grid doesn't care about elegant lab numbers at 20 degrees C if the truck is stuck at a border, the invoice fails a traceability check, or the refinery's turnaround slipped because TCRCs went thin. Reliability now lives in logistics, contracts, and standards as much as in copper atoms. Get this, the doctrine is simple in sentence form and brutal in practice. Own the choke points you can, refining where electrons are cheap, recycling where purity is provable, standards where your preferred hardware is the default. Then neutralize the choke points you can't, dual-spec designs that accept AL or CU with certified interfaces, offtakes that tie mines to mills to motors, stockpiles that flatten the worst week of the year. The physics gave copper the crown, the planning decides who wears it. You can see the doctrine in how clusters behave. China turned refining into a utility function co-located with factories, ports, acid offtakers, and service techs. When TCRCs collapsed, plants kept running because the cluster was the margin. Sulfuric acid fed chemicals, anode slimes fed precious metals, wire rod fed downstream orders that didn't stop because a spreadsheet said they should. Elsewhere, standalone smelters felt every price twitch like a body blow. Control, not conductivity, separated the steady from the shuttered. The West's emerging answer mirrors that logic without the same command gear. Put refineries in hydro grids, Quebec, British Columbia, Scandinavia, so carbon runs low and power stays boring. Tie financing to offtakes from OEMs who publish copper intensity targets and loss reduction plans. Let those contracts carry bankability where the spot market woe. Then make the standards do quiet work. Pre-approve AL-CU transition kits, embed inspection cadences into commissioning, require torque audits the way you require insulation tests. A code clause is a supply chain instrument if you write it that way. Recycling is where doctrine and decarbonization meet. Secondary copper saves energy by orders of magnitude, but only if it's clean and traceable. That means funding disassembly lines that turn EV motors and industrial busbars into known feedstock, not mystery metal. Hydromet circuits tuned for impurity windows become extensions of refineries, not rivals. The winners here aren't the yards with the biggest piles. They're the plants with the tightest assays and the longest offtake list. Again, control beats conductivity. Standards are the quietest lever. If a national code board writes aluminum feeders as allowed if instead of allowed, the if becomes a contract. Bimetal pads from a listed vendor, oxide-inhibiting compound brand specified, torque curves recorded and stored, thermography within 90 days, recertification every 2 years. That bundle turns an abstract risk into a managed routine. It also turns a supplier universe from unbounded to approved, which matters when a project is 70% complete and a missing elbow can delay an opening. The doctrine says, write the spec so a pivot is a switch, not a redesign. Friendshoring is the geopolitical translation. If you can't mine fast enough at home, you put refining with allies who have clean grids and predictable politics. You stitch value chains with clauses about origin, impurities, and recourse that are boring on day 1 and invaluable on day 400. You accept that a refinery permit will take time, then you give the agency a shot clock and the staff to run it. Control looks like patience on paper. In practice, it's speed that doesn't decay under scrutiny. Here's the uncomfortable part. This doctrine prices maintenance as strategy, not overhead. Aluminum feeders save capex, but only if the torque wrench shows up on schedule. Copper bus forgives, but only if procurement keeps a second source refinery on retainer when one goes into maintenance. Training isn't HR, it's uptime. A thermography route is a capital allocation decision spread over Saturdays. The systems that win are the ones that fund discipline as if it were fuel. Markets are slowly rewarding control. Project finance terms sweeten for refineries tied to hydropower and multi-year OEM offtakes. Recyclers with chain of custody certifications get lower cost debt than scrap traders with volume and no assay. Utilities with documented loss reduction and inspection cadence glide through rate cases that sink neighbors who optimized for day 1 capex. Hyperscalers pay premiums for low-carbon cathode because they've already learned the price of a hot joint is higher than the delta in a contract. Conductivity still matters, it's just not the tiebreaker anymore. Meanwhile, design efficiency acts like a shadow refinery. Automakers moving to 800-volt platforms cut current enough to trim copper mass without touching the torque curve at a single lug. Utilities specifying higher-grade steels and better winding geometry, and transformers buy back loss reductions that would have taken miles of heavier cable. Data centers standardize busway modules for reuse when halls shuffle. Copper kept in service instead of downgraded to scrap. Each of those choices is a control surface. Fewer kilograms needed, fewer surprises shipped. The doctrine even reframes risk. A single vendor miracle part looks smart until an export license changes. A dual spec design looks expensive until a maintenance delay turns into an outage you can't PR away. The portfolios that perform in this decade won't be the ones that guess the copper price. They'll be the ones that bought optionality on logistics, standards, and training, and treated negative TCRCs as a signal to build buffers, not to pray for mean reversion. This isn't an argument against copper. It's an argument for respect. Respect the physics by saving copper for where terminations are dense and access is scarce. Respect the calendar by placing refining where electrons are clean and steady. Respect the workforce by writing maintenance into money. Respect the politics by building value in country where the ore comes out. It's unglamorous. It's how systems carry load without headlines. Control beats conductivity when the grid is hot, the port is slow, and the invoice has to clear. That's the quiet doctrine. It won't trend, it will keep the lights on. In the end, copper's future won't be decided by purity alone, but by who controls the steps that turn rock into reliable power. If you want the next chapter, how this doctrine reshapes data centers and EVs, watch the next film. Subscribe to stay ahead of the supply shocks and share this with the one person on your team who owns the torque wrench and the contract clauses.